Good evening. We are Team 3. I'm Jingxian. Our members are Tian Tian, Junjie, and Jingchuan. Singapore Power Service supplies electricity to households and businesses in Singapore. The rate for electricity, gas, and water are on a flat rate. If there is dynamic pricing, means that the rates are different throughout the day. Is the energy consumption be affected by the rate? UK has a target of getting 15% of its energy supply from renewable sources by 2020. However, matching the residential electricity demand characteristic by static P to variable and aggregator supply of wind power is a major challenge, and also we download the data from London data store, which is created by the Greater London Authority as therefore stamp towards free London data, and the data is contributed by UK Power Networks. The size of downloaded data is 11 GB, and this is huge data set. The data is in CSV format, and the dataset contains 167 million rows collected from a sample size of 5,533. Let's see a sample record. The first is the ID of sample household, and the next is standard or time of use. The third column is daytime. It means the recorded date and time. The next is the energy consumption, and the last one is customer classification. And let's see, this is the sample number of our data. Our analysis process is shown here. We download a CS file from London data story and up it onto Amazon S3 so that the rest of the member is able to access the data. And we use Jupyter Notebook and Python to do the analysis.
Now go to our analysis. Firstly, we calculated the average energy use in months from 2012 to 2014 by three customer clusters. We choose the line charts to show the fluctuation of energy use in three groups by time. Then we choose a specific year, 2030, to show the seasonal variation. According to the weights of charges, stand and dynamic time of use, we draw two lines to show the average energy use from the 2012 to 2014. And then we choose a specific year 2030 to see the seasonal variation of average energy used in two ways of charges. Now we go to the breakdown of tariff charges from December of 2013. And we draw the average energy used on the selected day for the standard charge. The chart shows there is a correlation between the high consumption and the high charges instant. And the average energy use on selected day for the standard charge, the dynamic time of use, there is no obvious correlation between the high consumption and the high charges. So sorry we haven't done the conclusion. Now we go to our running time. Now good in good computer we use the XX minis, and in the Spark cluster we use the XX minis. That is sure there is huge difference between them. Because Spark is an in-memory distributed compute engine that speeds up analysis on large-scale data up to 100x faster than current technologies. The average performance of Spark increased when we increased the memory bandwidth, cache structure, and thread density. With more CPU, Spark is able to launch more tasks to process data and distribute those tasks to independent logical.
So here is our challenges. We don't have enough memory in free tier to process 11 GB of data, so we set up a instance with 30 GB memory to handle all this data. It's quite expensive. Thank you.